Okay, so we are to determine if the equation is linear. Well, that means that it makes a straight line when you graph it. Okay. Now, we're not going to worry about graphing it at this point. But there are ways without graphing to tell whether or not an equation is linear. For example, if any of the variables have an exponent other than 1, the answer is no, it's not linear. If any of the variables are multiplied together, the answer is no, it's not linear. If any of the variables are in the denominator, the answer is no, it's not linear. But this last one doesn't have any of that stuff going on, so yeah, that one's going to be linear. So those are basically the tells that you're looking for. All right, so now we're looking at a graph of a function. Looks like an absolute value function, but you don't need to worry about that. And this function is, we're looking for the intercepts, the x-intercepts and the y-intercepts. Okay, remember, that's the x-axis, that's the y-axis, just like it's labeled right there. So x-intercepts are the points where the function in blue hits or intercepts the x-axis. So it hits it at x equals 0 and also right here at x equals 2. Now, I don't remember for sure how Alex wants the answer. I think right here is how Alex wants it. If not, then they just want the ordered pair for each. For this guy, it would be 0, 0. And for this guy, it would be 2, 0. Okay, because they're both at a height of 0. Anytime you're on the x-axis, your y value is 0. You're at height 0. You're not up here at a positive height. You're not down here at a negative height. All righty then. So we've got that. So what about y-intercepts? Where does this thing hit the y-axis? Well, it hits it right there, which happens to coincide with one of the x-intercepts. Yeah, that happens occasionally. So that's at height 0. And like I said, maybe they want it written like that, but if I recall correctly, they don't in Alex. So that's all you do. You just write it down. But you need to make sure you understand what y-intercept and x-intercept are, because it does get used throughout algebra, and you don't want to get lost on that. All right, so now we are going to actually graph a function. And let's see, let's do that. Okay. So we've got the y-axis, there's the x-axis, everything's wonderful and good in the world. Okay, so now we've got to find a couple of points. Well, we essentially have y by itself, or the name of the function by itself. And whenever that's the case, the number that is not multiplied by x, whether it comes first or not, that number is the y-intercept. That is where the line we're going to draw will hit or intercept the y-axis. So 1, 2, 3, 4, -5, right there. That's my y-intercept. Okay, and the number that is multiplied by x, that is the slope. And it's, when you're graphing by hand, it's handy to write it as a fraction, so 2 over 1, because that slope is the top of the slope is the rise, the bottom of the slope is the run, rise over run. So the top tells you how far we're going to rise. So from this point right here, we're going to rise 2. So 1, 2. Okay. And that's not where we're stopping, because we still need to run 1 unit horizontally. Okay. So we're going to run 1. Whoops, that's too far over. It doesn't run that. So we're going to go up 2 and then over 1 and end up right there. Okay, so that's going to be that line right there that goes through the 2 points. So the first thing that you do is you plot your y-intercept. Second thing, use the slope to find a second point, then play dot to dot. Okay, now be aware that this function here, that thing, you know, it's the same thing if I write this. Whoops. That's the same thing. The 5 is still negative and the 2 is still positive. The x is still multiplied by 2 and not 5. So, you know, the y-intercept is still -5, even though that number comes first. I bring this up because a lot of people, they just freak out. They're like, whoa, 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 I thought the first number was always slope. No, the number multiplied by x, that's slope. The other number, okay, that is the y-intercept always. Okay, so that's just something to be aware of. Now let's do it again, except this time we are going to be, well, now we got a fraction for the slope. Big deal. All right, it's really not especially important. It doesn't really change what we're doing very much, so that's kind of nice. It's not really like something new. Okay, so we'll go back to, I guess, that color. So the y-intercept is the number not multiplied by x. So we're going to go to a +3. Okay, right there. Isn't that lovely? Okay, and then the slope is 3/4. So that means go from that point, go up 3/4. And that's gonna put us at about there. Okay, they don't have a lot of choices on the stamps, so yeah, whatever. All right, and then this looks like a nice color. So then I'm gonna go, let's see if I can hit both points. Close. Let me try a little lower here. I'm not very good at this. Just there, that's better. Okay, anyway, you get the idea. And you play dot to dot again. And so it's really just like the last one. The only difference is on the last one, we had to put a 1 underneath the slope. And that was it. All right, so on this one, we're going to graph the equation. And this time it's an absolute value of x. So normally what would happen is we'd say, hey, it's y = 4x, which is the same thing as 4x + 0. So we'd have a y-intercept of 0, a slope of 4/1. So up 4/1. We put a point there, and then we would draw that line right there. Okay. Yeah, that's cool. But here's what happens. Because of that absolute value says, hey, I only do positive stuff. It's kind of like prima donnas in basketball. Hey, I don't play defense. I only do offense. Anyway, yeah, they don't do any negative. You know, this is never negative. So therefore, y is never negative. So this stuff down here is not going to end up down there. Okay, in fact, it ends up right there. Okay, and it's just a mirror image of the stuff on the right. Okay, and that's what it's going to look like. Let's take a look at that on the calculator. I want to do the last one there, but I forgot to do it. So 4 times the absolute value of x. Let's clear this out. Do that. Okay, so I'm going to go to y equals and clear out the last stuff. Then I'll go 4, and then for absolute value, that's math, right, enter, and then I'll stick in the x. And then when I go to graph, hey, that's what we got a moment ago. Isn't that special? Okay. And anyway, that's kind of how we do it. Now, an alternative way of doing this would be to just say, all right, well, let's just get some points, and then we can play dot to dot again. So I don't know, maybe like let's grab maybe like -2, -1, 0, 1, 2, pretty standard stuff. And then say, all right, well, when x is -2, what's y? Whoops, not that. Well, it looks, oh, I wrote it wrong. 4 times the absolute value of -2, which is 4 times 2, which is 8. All right. What about when x is -1? That's 4 times the absolute value of -1, which is 4 times 1, which is 4. And for 0, 4 times the absolute value of 0, which is 4 times 0, which is 0. And then a 4 and an 8, doing those same things. Okay. And then you could just say, all right, so I know the point -2, 8 is on the graph. So, -2, 1, 2, 3, 4, 5, 6, 7, 8. So -2, 8 is on the graph, and the point -1, 4 is on the graph. So that'll be about there. And the point 0, 0 is on the graph. And the point 1, 4. And the point 2, 8. And would you look at that? It forms that same shape we've already done twice before. Okay. So that would be, another way to do it. A good way. That's the way Alex does it. All right. So on this one, we're supposed to plot 5 points and then graph it. Okay. So we need to go get those 5 points, and they give us really good, specific instructions about that. They say, all right, you're going to want to use x equals 0 and then a couple of negative values. I always use those, and a couple of positive values. Okay, so let's try this color. I don't care for it, but I don't use it very often. So we'll go H. I can hardly see that. Maybe it's because I'm colorblind. Let's do this. H of -2 is going to be -4 times -2 squared plus 5. Again, H of -2, that just means when x is -2, what's y? Let's find out. So we get a 4, and then a -16 in there, and then a -9. All right. And in the interest of time, I'm going to do the rest of it off camera. And there it all is written out, and I fixed that mistake with the -9. It really is -11. Okay, so now I would play dot to dot. Okay, and so I need a graph here. So we got that cool looking thing, and go back to this. All right, so I know that the point -2, -11 is on the graph. So let's go about right there. So the -11 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and I think it's time for another heart. Actually, I'll do stars this time because that'll be super cool. So there's a star right there. Okay, don't know how well you can see it, but it's right in there. Okay, and then we've also got, let's see, the next point is going to be -1, 1. All right. So, -1, 1. Oh, wait a minute. I got to draw some of those lines, don't I? 1, 2, 3, 4, 5. Okay. So -1, 1 is going to be right there. Okay. See him right there. All right. The next point is going to be 0, 5. And so that'll be right about there. Let me get that just a little better. There, that's a little better. Okay. And the next point is 1, 1. So that'll be about right there. And the last point is 2, -11, which will be about right there. So now we can play dot to dot and say, all right, well, it looks like, oh, doggone, I got to do it from the right because then my hand gets in the way. That's better. Okay, and then that's what it would look like. And of course, you could do that on your calculator, and that would be splendid, which we'll do right now. So I'll go -4x² + 5. Let me double check I got that. Yeah, okay. And then when I hit graph, it looks like what I did, pretty much like what I did a moment ago. Okay. All right. All right, so now let's tinker with not a quadratic or a linear function, but with a radical function. So it says, all right, well, just, they give you the x values, plug them in. So we want to do, whoops, that's messy, f of -57, because they give us the x, we want the y. So when x is -57, what's y? That'll be the square root of 7 minus -57. Now, notice it's minus a minus. Those both become plus. What a lot of people will do, erroneously, is they'll just say, oh yeah, square root of 7 minus 57. It's like, whoa, whoa, whoa. That minus needs to be in there. And this minus would also need to be in there. Okay. So that's something to avoid. All right, so that gives us square root of 64, which is 8. Cool. All right, so that tells us -57. That's in the domain of the function, because when we plug it in, we actually get an answer. We don't end up doing square root of a negative. So -57, that's in the domain. How about -29? So f of -29 is going to be 7 minus -29, which is 7 plus 29. That's 36. And we get 6. Yep, we got an answer. Doesn't have to be a nice answer. It can be like 6.9832. Well, we got an answer. So -29 is in the domain. All right. How about let's go this color, I guess. So how about f of 7? Ooh, okay, I don't know. So that'll be square root of 7 minus 7. So square root of 0. And 0 times itself is 0. So yeah, okay. So 7's in the domain, gives us an answer. Last one. F of 16, which will be square root of 7 minus 16, which is square root of -9. And doesn't work. Okay, we're not doing square roots and negatives. So yeah, it doesn't work. And 16 is not in the domain. Okay, that is not in the domain of the function. You plug it in, you don't get an answer. Now I can check this out on the calculator because it's super cool to do so. That's the main reason. So if I plug in the function, square root of 7 minus x, into my calculator, so square root of 7 minus x, okay. And then now the y value or the x values I want to plug in, they're kind of all over the map. So instead of just going straight to the table, I'm going to go second window, and I'm going to tell the calculator, hey, let's go into ask mode. So the calculator is going to, in effect, be asking me for x values instead of automatically populating the table. So when I go to the table, if you have any numbers, just hit the delete key until they're gone. So I want to know what's going on when x is -57. And when x is -29, I'm just typing those numbers in. When x is 7 and when x is 16, bam. And there's that error to say 16 is not in the domain, doesn't work. 860. Yeah, see how slick that is? Anyway, that is how it's done. Typically, I like having my table in auto mode, but you know, not always. Sometimes I like this when I got to go all over the place to find the to plug in the x values. I definitely prefer ask. Now on these, we get to classify the graph of the function. Okay, which one is it going to be? Now, when the highest power of x is 2, that means it's quadratic. So it's looking like that or like that, one or the other. It's going to be one of those two. It will not be a straight line. So vertical lines are straight lines, horizontal lines are straight lines, a line. So it won't be any of that. It'll have to be a parabola. Okay. Whoops. Okay. So is it a parabola opening up or opening down? Well, you just look at the leading coefficient to determine that. And the leading coefficient is the number multiplied by x squared. Well, in this case, that would be the implicit 1, positive 1. And because 1 is positive, it's a parabola opening up. And you could always just plug this in your calculator, hit graph, and you'll notice it looks like that. Okay, it opens up. Cool. So what about part B? Well, I don't see an x squared in there, so it's not a parabola. Okay, so the deal's off on those two. And to be honest, just to kind of shortcut this, when there's only one variable in the equation, like just x, or in this case, just y, because h of x, the function name, that's essentially y. That tells us we're either going to have vertical or horizontal. Okay. So when you have just y, that is going to be a horizontal line. Why is that? Because again, what this function here says is basically y equals -4. So this equation says I'm looking for all points with a height of -4. Well, -4 is right there, so all of these points are all down -4. They all have a height of -4, and when you play dot to dot with them, you get a horizontal line. Okay, so if you want to remember that, go explain it to somebody. If you don't expect to remember that. All right, the last one. Let's go that color. Okay. Well, there's no x squared in there, so we know that it's not a parabola. It's I see both variables, x and y, or k of x. So I know it's not vertical or horizontal. And so it's going to be a line that's either going with a positive slope or with a negative slope. We read graphs from left to right. Okay. So, from left to right, this one is going up. So that's positive slope. And this one is going down. So that's negative slope. So the slope here is positive 4. So we know has a positive slope. Okay. It's going to be going up from left to right. Okay, so graphing an absolute value equation. Let's see one way to do it. Now, of course, you can on this. You can plug this thing into your calculator and see what happens. Okay, so we got that. In fact, you know what? I think I'm going to do that. Not on the graph, but I use the table just because I feel like it. And yeah, I think that'll be super groovy. Okay, so I need to plug in some points. So I'm thinking like -2, -1, 0, 1, and 2, like I did on those other two in this video. But I am going to do it on the calculator. Okay, so first I got to plug this function into the calculator. Righty, so I'm going to go -2 and then math, right, enter for the absolute value of x plus 2. And then I need to do the -3, but outside the absolute value. So I hit the right arrow. Now I do the -3. Yeah, I was like, is it -3? I thought it was. Okay. And then I'll go to the table, and those top 5 are the ones that I want. So when x is -2, y is -3. All right, so let me put on some tick marks here. So we're going to go about there, 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 and there. And let's see, we need to go to about -11, huh? Okay, 1, 2, 3. Oh, didn't do that very good. 4, 5. Let me use my pen. 6, 7, 8, 9, 10, 11. Okay, so that bottom one is -11, and I'm interested in that because out of all the y values in there, that's the smallest of them all. Okay, so oh, I'm still using that. All right, so let's do our thing here, and I'm gonna go to where's those stamps? Those are nice. Let me go back to hearts because that's fun. Okay, so I need -2, -3. So left 2, down 3. And then I need -1, -5. So left 1, down 5. 1, 2, 3, 4, 5. So about right there. Then I need 0, -7. 2, 3, 4, 5, 6. So about right there. Then I need 1, 9. So right 1, down 9. And then 2, -11 is about right there. So notice what's happening here is, whoops, wrong one, is we are really just getting that line right there. I know I didn't hit all the points because I'm not the best drawer. So what's that really going to look like? Because one thing we've learned is that, where do I want to go? Oh yeah, one thing we've learned is that when you are doing absolute value in your function, that you get either a sharp point and and the graph opening down, or sharp point with the graph opening up. You get one of those two. Okay. Well, we could find out real easily and just go to the graph. Oh, it's opening down. Cool. Look at that. All right. So yeah, look, it looks like the graph starts going down again when x is -2. So right here at -2, that's when it should have started going down, but we didn't plug anything into the left of it. So, if we take a look at the table, whoops, I don't know what I did there. Okay. If you take a look at that table, notice once we get past x equals -2, those y values, they start dropping again, down to -5, down even further, down even further. Okay, so that would have been what what it should have looked like was just kind of coming down and then going back down again once you get there. But that's what you're going to do is plug points in, and you can do it by hand like I've done earlier today more than once, or you can do it on the table. You need to know how to do it both ways.